Hello everyone, welcome to today's video. In today's video, we are going to speak about inequalities. This session is going to be the extension of the previous session. And this session is going to be focused on x square and x. Okay, so let's get started. Okay, I will start this session with an inequality a less than b. Okay, so this is the given inequality. Okay, now see here, if a is less than b, then it does not mean that a square is less than b square is always true. Okay, it may be true, it may not be true, but saying that it is always true is a wrong thing. Okay, so if a is less than b, then a square is less than b square. This thing is not always true. Okay, we will see it from the example. Okay, let's take an example here. I'm taking 10 here, 20. So of course 10 is less than 20. If I do squaring both sides, it's going to be 10 square, it's going to be 20 square. So this is going to be 100, this is going to be 400. So here the sign of inequality is not affected, right? So it remains the same, right? Now let's take a different case here. Here I can say minus 10 here, 5. Okay, now I know minus 10, it is less than 5. Okay, now if you do squaring both sides, then see how it's going to behave. Then here, 5 square. Now, square of negative number is always positive, so this will give you 100, here 25. Now look at the sign of inequality. Now it is greater than. So here you can see that the sign is changing, and here we have seen that the sign remains the same. So that's why I had told that if a is less than b, then a square is less than b square. It is not always true. It may be true, it may not be true. Okay, so we have to check. Understand? Now, let's take few more cases. Okay, here, if x is greater than a, okay, for all positive a's, right? If x is greater than a for all values of a to be positive, then I can say that x square is going to be greater than a square. Okay, we can see it on the number line. So let's take any number on this number line greater than 0. Okay, let's say this is 7. Okay, now if x is greater than 7, then what do you think about x square? Now, if x is greater than 7, then x square, it's going to be greater than 7 square. Okay, this is true, right? If I ask you, what do you think about if x is 9? Then again, if x is greater than 9, then your x square, it's going to be greater than 9 square, which is 81, right? Because what does it mean here? Here, it says x is greater than 7, right? So it means x will take all the values greater than 7, right? Up to infinity. Okay, and if the lowest value that x will take, it is just the closest value to 7 on the right. Okay, so x is all the value of x square, it's always going to be greater than 49. So this thing makes sense and this thing is true. Okay, I hope you understand the point. Now If I ask you, what do you think about x is less than 5? Okay, so what's your opinion about if x is less than 5, then how x square is going to behave, or what values x square is going to take? Okay, so now see here, if this is the case, then uh, here I have 0, here 5. Now x is less than 5 means that 5 is not included, and they are talking about this side, right? So x can take any value less than 5, okay, up to minus infinity. Okay, now this thing, if I want to break it down, so can I say here x, here from here I am going to divide this whole thing into two parts. Okay, this is your 0, or I'm going to use red for this. So this is your x equal to 0. So one part where the value of x lies here between 0 and 5, and the other part where x is less than 0. So here I would say here x is less than 0, and here x is going to stay between 0 and 5. Here, why did I take the closed one? Here, why did I include 0? Because here I did not include 0. Okay, because it says that the value of x is less than 5. Okay, so 0 will be part of it, right? Now if you look at this interval, okay, if x is between 0 and 5, then how x square is going to behave, or what values x square is going to take. Okay, now between 0 and 5, right, including 0, x square, it's going to be, it's the minimum value is going to be 0 at x equal to 0, and the maximum value here in this interval is going to be 25. I hope you understand it, right? Because see here, this is 0, okay, this is 5. Okay, so the minimum value is going to be at x equal to 0. So here x square is going to be 0, and this is the highest value in the interval of x, right? X equal to 5. Okay, so here x square is going to be 25. So I would say x square will lie between 0 and 25, including 0. Okay, and here for x less than 0, now here all the values are negative, right? X will take all the negative values up to minus infinity, and if you do the squares of all these negative values, what would happen? You will get the positive values if you keep on moving towards the left. So x square is going to take bigger values, right? Which means that here in this interval, x square is always going to be greater than 0, right? I hope you understand my point. So if I look at both these intervals, I can deduce some result from here that our x square is always going to be greater than 0. Okay, I hope you understand it. Okay, so the best way I think to get to this result is that whenever you are given with the interval of x, we have to check if 0 lies in that interval. Okay, so the minimum value of x square is going to be 0, because 0 is going to be the least value for x. Okay, so at that point, x square is going to be 0. And for all the positive values on the right or the negative values on the left, x square is automatically going to take the higher value. So we can say x square is greater than 0. Okay, let's take one more example, then you will have more clarity on this. Here, let's say that my x is less than or here x is less than 9. Okay, x is less than 9. So if x is less than 9, what about the values of x square? Okay, now x is less than 9. Okay, uh, so we'll visualize it on the number line. Here it is 0, and here we have 5, here we have 9. Okay, now x is less than 9 means they are talking about this interval. Okay, all the values of x that is less than 9. So we can break it down into two intervals just for more clarity. The first interval, it is from 0 to 9, and second interval, this one which is x less than 0. Okay, now for this interval, the value of x square, it's going to be between 0, including 0, and it will go up to 81. Okay, so x square will take the minimum value of 0, and the maximum here it will take is 81, right? But now if you look at this side, okay, this is for this interval. Okay, now if you look at this side, the left side of 0, x less than 0, here x square, it's going to be greater than 0, means that x square, it's going to take any value. It's going to take, and because here, uh, see here, sorry, here it's going to be greater than 0, right? Not equal to 0. Why? Because this is less than 0. So here x square will take any value between 0 to infinity, right? So if you combine both the results, we can say that x square is going to be greater than equal to 0. Okay, this is very obvious. Why? Here it's going to take any, x square is going to take any value between 0 and infinity, because if you keep on decreasing x, the value is going to be more negative, and the square of negative value is going to be positive. It means you will get higher and higher values if you keep moving towards the left. Okay, I hope this thing is clear to you. Okay, now if I ask you, what do you think about if your x is greater than -3? Okay, so if x is greater than -3, then what would happen? Now see here, we will visualize it on the number line. This is 0, this is -3. Now x is greater than -3 means that they are talking about this interval, or I can say this is -3 to infinity. Now, what's going to be the minimum value of x in this interval? Now, see here, x will have its least value at x equal to 0. So at x equal to 0, x square, it's going to be 0. So I would say that for this one, the value of x square is going to be greater than 0, right? Because the minimum value of x is at 0, and for other values of x, the x square is going to get higher and higher values, but x square is going to get the least value at x equal to 0. So that's why x square is greater than 0. I hope this thing is clear to you. Okay, now let's take few more points. What if, okay, what if x lies between two positive numbers? Let's say that here 1 and 9. Okay, if x lies between 1 and 9, then what about x square? Okay, what about x square? So you can just draw the number line. Here we have 1, here we have 9. Now if if x is between 1 and 9, means they are talking about this region. So here we know, see here, 0 is here. So in this case, because the given interval doesn't include 0, right? Because it lies on the right side of the 0. So here we can say that the x square will take the minimum value of 1 and maximum is going to be 81. Okay, so when you are given the two positive numbers, okay, then you can just do the squaring on both the sides to get the value of x square. Okay, what if one side you have negative, other side you have positive? Let's visualize it. Let's say that our x, it lies between -3 to 5. Then what about the value of x square? Now see here. Again, the key thing here is that we need to find where is 0. Is 0 included in the interval or not? Okay, let's say that this is the given number line. Here I have -3. Here I have 5. Now, tell me one thing. Does 0 lies between -3 and 5? And you will say yes. Okay, so what does it mean? It means x square will have its minimum value 0, right? So here I can say that this thing will be this thing. If you take the square of x square, then minimum value it's going to be 0. Okay, 0. And the maximum, now see here, which number is greater here? Of course 5. So as we move along, so we can see the highest value that x square can take, it would be at this 5, right? So here it's going to be 25, but it is not included here because this interval is open. Okay, so x square will lies between 0 and 25. I hope you understand the point. Okay, now what if x has negative numbers on both the sides, or the interval that we are going to take for x, it has negative numbers? Okay, let's see. uh, I can do it here. Okay, we'll clear some space there. uh, Here, if x takes value between uh, let's say here -8, here -2. Again, the same thing, you have to check for 0. Does 0 lies in this interval? I think no. Okay, because if you draw a number line, here you have 0, here we have -2, here we have -8. Okay, now see here, they are talking about this interval and 0 is not included, right? So what about the value of x square? Now x square will have minimum value at -2, right? So here 4 and here 64. Understand? So quite easy. Just we have to look at, is 0 included in the interval? If 0 is there in the interval, then the minimum value that x square is going to take is 0, right? Or it will be 0. But if 0 is not included in the interval, then we can just do squaring on both the sides, and then you can find out like what possible values uh, could x square take, right? So this was very important concept, because uh, not sometimes, but more often, we are going to use this concept in the question. It's very simple concept, but most of the time we make mistakes. Okay, so just keep this thing in your mind. Now, if I ask you some things here, if I say that if x square is, if x square it is greater than minus 2, then what's going to be the value of x? Then what's going to be the value of x? Now see here, if x square is greater than minus 2, I mean x square is always greater than 0, right? It is always going to be greater than 0 because x square, it's going to give you the positive number. Even though if x is negative, x square is always going to give you the positive values. So here I can say that x will belong to all the real numbers. Okay, if someone asks you what about x square less than minus 2, so now you can see here x square less than minus 2 means that your x square is negative. And how can x square be negative? It is square, so it has to be positive. So it means that x belongs to null or phi, right? So just keep these things in your mind. These are basic things, but these are very important. Okay, now uh, let's do one important result. Okay, uh, what this result says, this result says that if your x square is less than a square, right? If your x square is less than a square, then your x is going to be between minus a to a. Okay, minus a to a. That's what it says. Okay, and second result says that if your x square is less than a square, then x belongs to minus infinity to minus a union a to infinity. Okay, now let's try to see if this result is valid or not. Okay, let's say that we can take this case, x square is less than 9. Okay, and here we will take x square less than 25. Okay, now uh, there are lots of ways to solve this inequality. Okay, but here I'm just going to use the most simplest way that we can go for. Okay, so now if I write here x square, it is less than 3 square, then you won't mind it, right? And then if I draw a number line here, then I have to find 2 points, right? Here, minus 3, and here, 3, because I know that square of 3 is 9. So I took here, I have 0. Okay, so I took 2 points on the number line for whom I think that if I square those numbers, the value of x square is going to be 9. Okay, now tell me that where these are the values of x, right? Now tell me where x square is going to be less than 9. Now, if you look here, if you keep on increasing the value of x this side, what will happen? X square is going to be greater than 9, right? Similarly, if you decrease the values towards the left, what would happen? Again, the x square is going to be greater than 9. Why? Let's say that here value is minus 4. So minus 4 square is 16. So that is greater than 9. Okay, so it means that we cannot take these values, right? We cannot take these values because here x square, it is greater than 9. Okay, so what values are we left with for x? These values, right? So here I can say that if x square is less than 9, then my x, it's going to be, because these are included, right? So here solid dot, so it's going to be minus 3 to 3. I hope you understand. Okay, let's take one more case here. I can write x square, it is less than equal to 5 square. Again, we'll visualize it on the number line. Here, I take 0, here minus 5, here 5. Okay, now if you take any value of x greater than 5, means if your x lies in this region, then here x square is going to be greater than 25. Why? Take 6. Square of 6 is 36. It means, so you cannot take these values of x, right, greater than 5, right? And similarly here, if you keep on decreasing the value of x, then the value of square, it's going to to take higher values, right? So it means that in this region, x square is going to be greater than 25. So what region are you left with for x? This region. And this is going to be the solid dots, means they are included. So this region. So here your x belongs to minus 5 to 5. So that's what it says, that if your x square is less than a square, then your x should be it should lie in this interval, closed interval, minus a to a. Okay, but if here, now see here, if here you have x square less than a square, okay, if you have here x square less than a square, then what would happen? Then your x is going to be lie between minus a to a. Okay, here, because I haven't included, here the intervals are open, here they are closed, because here we have equal to sign. Understand? So this will give you this, and this will give you this. I hope this is clear to you. Okay, now take the second case, this one. If x square, it is less than, I hope this is visible, right? All right, yes. Now take second case, when your x square is less than a, sorry, sorry, when your x square is greater than a square, greater than a square. Okay, so when your x square is greater than a square, so here I will take the same example, x square greater than 9. Okay, so if x square is greater than 9, then here I can say x square is greater than equal to 3 square. Again, I will draw the number line. I will locate these 2 points, minus 3 and 3. Okay, now here 0. Now see here. Now these are the values of x, okay, on the number line. So if you take values greater than 3, so for all these values, x square is going to be greater than your 9, right? So this region is included, right? And if you take all these negative values, okay, if you keep on decreasing the value of x, then you will get higher values of x square, means it again satisfies this. So for this region, yes, x square is going to be greater than 9. For this region, x square is going to be greater than 9. So we have to include here, because here we have equal. So here I will just use solid dots. So I would say that my x would be from minus infinity to minus 3. And see here, 3 is included, union, and here from 3 to infinity. 3 to infinity. Okay, I hope you understand this. Okay, so that's what they said here, that if your x square, it is greater than a square. Okay, greater than a square, then your x is going to be from minus infinity to minus a union a to infinity. Okay, open, closed, closed, open. Okay, and this is for this, and if your x square is less, sorry, it's greater than a square, then your x belongs to minus infinity to minus a union a to infinity. Okay, open brackets, open interval. Okay, so I hope this is clear to you. These are important things because when sometimes it happens that you are applying it, but then you get confused and then the whole question gets wrong there. Okay, so you must have a thorough understanding of this concept so that you can easily apply this concept whenever you are trying to solve the inequality that involves x square, or where you have to look for values of x from the given values of x square. Okay, so that's all about this session. I will see you in the next session. Take care of yourself. Thank you very much. Bye bye.